Okay, here's another example of using trig identities in a coordinate plane to solve a question asking, for example, cosine of one angle plus another, where, here's the challenge, we are not given all the information about the angles that we need, at least not to solve this very, very quickly. We're given enough to solve it, but we're going to have to work a little bit. And you can see what we have here. I'm going to start off, let's call beta my blue color. Okay, so I have cosine of beta. That's nice. I would love to know cosine of phi also, but I don't have that. And what else do I have? I have sine of phi. I would like to know sine of beta, but I don't have that. In their place, I have these things. I have some information about phi being in quadrant 3, and I also know that beta is in quadrant 2. So let's try to put that together with some triangles. And I'm going to make a triangle for each one. The key here is drawing your triangle in the correct quadrant. So beta, like we said, is going to be in quadrant 2. This does not have to be an accurate triangle. It just has to be in the correct quadrant. Okay, and typically when I'm drawing these things, you'll see that some sides just look ridiculous, right? They're just way off. But who cares? As long as it's in the right quadrant, it's going to help me keep my signs straight, my pluses and minuses. And that's the important part. Now, if cosine is negative 5 over 7, what does the 7 have to be? The 7 should be pretty clear. That's the hypotenuse, because cosine is, remember, cosine equals adjacent over hypotenuse. So there's my 7. How about that 5? Well, that's going to be the adjacent side, the x value right here. And remember, here's the important part, it's a negative 5. And you can see that from the cosine value and from the direction on the grid. I'm going to the left. And for the, let's see the next one, for the phi value, let's draw another quadrant over here. And this one's triangle is in quadrant 3. And let's just put phi right there. So phi is in quadrant 3 now, and I need to say sine is negative radical 32 over 6. Well, the over 6 part is easy. That's the hypotenuse. The negative radical 32, think about that for a moment and say, okay, well, that must be down here, because sine is, if you remember, that's opposites over hypotenuse. And the opposite from phi, the way I've drawn it, is that vertical side going down. Because it's going down, that's a negative value. All right, so now we're ready to complete the triangles. And what we have to do here is Pythagorean's theorem again. I'm going to call this side, oh, I don't know, we'll call that b right there. So I'm going to say b squared plus negative 5 squared equals 7 squared. So work that through. B squared plus 25 equals 49, which means b squared equals 24, which means b is the square root of 24. Okay, so we can just scratch out b and put in square root of 24. You don't need to simplify these things just yet. We can get to that later on if you want. Okay, looks like I got some old work in here. Let's clear that out of the way. And for this triangle over here, let's just call that side A for argument's sake. And I'm going to say a squared plus, put this all in parentheses, negative square root of 32 squared equals 6 squared. That's the Pythagorean theorem at work. And now as I work through this, I see a squared plus, well, square a negative, it just goes away. Square a radical, that goes away. So all I have left is 32 equals 36. So that means a squared equals 4, which means a equals 2. Well, that's great. Now, here's a point I kind of breezed over before when I was talking on this side. Square root of 24 is just radical 24, right? But it could also be negative radical 24. We have to be careful in how we choose that plus or minus sign. In the end, I chose a positive sign because I see this thing going up. Now this time, keeping in mind that it should be plus or minus 2, we have to pick this smartly. I think that's going to be a negative because I see this thing going in a negative direction. Okay, if you look, it's going to the left. That's a value of negative 2. So we choose our plus and minus carefully based on the picture. Okay, so the triangles are complete. Now it is time to go ahead and solve our problem. So cosine, if you remember, cosine changes the silly sign. So that means cosine of beta plus phi equals cosine of beta cosine of phi minus, that's its sign change, minus sine of beta sine of phi. So now we just plug in these values from looking at the triangles. So cosine of beta, what's that? Well, adjacents, I think we were given this one, right? Negative 5 over 7 times cosine of phi. Well, cosine of phi is over on this side now, and that's going to be negative 2 over 6 minus sine of beta. That's one of the new values we just got. Radical 24 over 7. And sine of phi is negative radical 32 over 6. Okay? Simplify that. Don't just leave it like that. That's terrible. We can do some more to work with this. At the very least, I could put it all in a fraction of 42 in the denominator, right? We know that 6 times 7 is 42. I can see common denominators. And now let's just simplify a little on the top. Negative 5 times negative 2 is 10. Negative radical 24 times negative radical 32. I mean, at least we could say this. We could do this much, even without a calculator. Okay, and if you don't have a calculator, fine, just leave it like that. Punch it in. But if you do have a calculator, you want to simplify this a little bit, go for it. I'll leave you to work that out on your own. It's not really crucial to this video, but that's the idea. That's how we find the missing information using a standard coordinate plane.